Hello and welcome back to my channel. Today in this video we are going to discuss Cambridge Mathematics 9709 paper 5, that is probability and statistics 1, the last few questions 5th, 6th and 7th from this Feb March 2021. And here is the question number 5. A driver records the distance traveled in each of 150 journeys. These distances correct to the nearest kilometer are summarized in the following table. It is given here. A part is to draw a cumulative frequency graph to illustrate the data. So before that we will make a cumulative frequency table row here. Let me write cumulative frequency. So for cumulative frequency we will write till 4 less than or equals 4 we have 12, less than or equals 10 we are going to add them, so 12, 16 plus 2, 18, 10, 28, and then here it would be less than or equals 20, and that is going to be 80, 30, 30, 30, 60, and then it is going to be less than 30, and here 60 plus 66 is 126, and here it is less than 40, less than or equals 40, it is going to be 126 plus 20, 146, and the last is going to be till 60, including it is going to be 146 plus 4, 150. Now we got from here two data, one on the x-axis, on the horizontal axis we'll mark these points, and for the bar cumulative frequency for this y-axis we have 12, 28, 60 and 126, 146 and 150. So once we have all these data, I will draw it here. So here we can see the data from 0 to 65, 60 I need, so I took the distance of 5, and it is 4, this is 4, the next one was till 10, then till 20, then till 30, then 40, and then till 60 we require, and I have marked the points, like here it was 12, then it is 28, so it is 28, there is a gap of 2, and it is 60, and then it was 126, and here 146, and the last one 150. So this is the cumulative frequency graph. I hope it is clear. Let's discuss the next question now. And here's the B part. I copied the cumulative frequency graph here so that we can see the question properly. For 30% of these journeys, the distance traveled is d kilometer or more. Use the graph to estimate the value of d. This is a question of 2 marks. So we can see it is given for d kilometer or more than that. So for instance, let's say this is d. If it is d here, so d or more than it is going to cover 30%. So it means from d we'll go back to our curve and then we'll find, let's say 30%. So more this top 30%. So if we need to find the top 30%, we have to calculate the 70% from the bottom, so that we can calculate the 30% from the tops. Means it is 30%, so it means from this bottom it has to be 70%. So 70% of total is, we can calculate from here, 70% of 150 is 15 7 105, so it is 105. Means at 105 we can see 105 would be somewhere here, so this is, let's say 105, this is 30%, and it says that if it is distance d or more, then it is going to be 30%. Means in order to estimate the value of d, we'll get back from 105 to the graph. This is the point on the graph, and then we'll come down for x value, means the distance. So it is somewhere here. So we can see it is either it is 25, 26, 27 or 28. So we can say the D value approximate, because it's an estimation question, so D can be either 27 or 28. I will take it as, let's say, 27 kilometer. We can give any value between 27 and 28. I hope it is clear. Let's discuss the next part now. And here is the C part. Calculate an estimate of the mean distance traveled for the 150 journeys. So what we are going to do here, I'll bring the table first of all. So here's the table. So in order to find the mean, we know the formula for mean. Mean is sigma of fx over sigma of f, means, and x is the midpoint in the case of interval, and f is given this as a frequency. The one thing we need to take care of, that there should be no number missing. It means there should not be any gap. There is a gap, 4 and 5, 10 and 11, 20 and 21. So first of all, we need to fill the gap, and filling the gap means we can divide this distance equally in both the intervals. So we can see 4 and 5 means there is a half we can add in the first interval, and we can add half in the next interval. And here we cannot go in negative, so the first interval would be 0 to 4.5, and the second interval would be 4.5 to, next again there is a gap of 1, so it means 10.5, half in this interval and half would be in this interval. So now there is no gap, so 10.5 to 20.5, and then here 20.5 to 30.5, and here it is 30.5 to 40.5, and the last I'll write here as 40.5 to 60.5. Now we'll calculate the mid value to get the x. So xi's, I can write xi, so it would be fi xi and summation of fi. Xi would be sum of these two divided by 2, means the mid value, and mid value is going to be 4.5 half, that is 2.25. Here it is going to be 4.5 plus 10.5, so 14 and 15 divided by 2, it is 7.5. So the mid value is going to be 7.5 here, and here it is going to be 20 plus 10, 30, 31, so it means 31 divided by 2, 15.5, and here it is going to be 25.5, and here in this interval it is going to be 35.5, and the last here the interval it is 100, and this, so it is 50.5, and corresponding FIs are given, so I will calculate directly the mean. So mean is going to be product of this with the frequency, and frequency is given here, so 2.25 into 12 plus 7.5 into 16 plus 15.5 into corresponding frequency, it is 32, plus 25.5 into 66 plus 35.5 into 20, and the last 50.5 into its corresponding frequency, it is 4. And we can see that the total frequency in the question itself, it is given 50, so 150, sorry, so we can directly write 150. Otherwise also we can add it here, it is going to be 150. So now we will calculate the numerator. So this value is coming 3238 and divide by 150. So we'll get mean as 21.586 and so on. So till 3 significant figure we will write our answer, and that is going to be 21.6, and it is distance. So 21.6 kilometer is the distance, mean distance traveled. I hope it is clear. Let's discuss the next one now. And here's the sixth question. Find the A part. Find the total number of different arrangements of 11 letters in the word caterpillar. So it's like find the different arrangements. There are 11 letters. So 11 letters can be arranged in 11 factorial ways. And then we'll see the duplicacy. So we'll remove that. We can see there are 2 A's, 2 L's, and 2 R's. So there we'll divide this by 2 factorial, 2 factorial, and 2 factorial, and that will be the answer. So it was easy because we have to only arrange it, no constraints, no conditions. So 11 factorial divide by 2 factorial, 2 factorial, 2 factorial, and that is going to be 4989600. So either we can write our answer till, oh no, in this way we have to write our total answer. Total number of different arrangement would be 4,989,600. These are the total arrangements. And here's the B part. Find the total different arrangements of 11 letters in the word caterpillar, the same, in which there is an R at the beginning and an R at the end, and the 2 A's are not together. So what we are going to do, I'll draw this condition here. It means first R is coming here, let's say, and the last R is coming here. I'll draw the 11 places first of all. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and this is 11. Now we are going to fix R's here, R here, and R here because of the condition, and we can see that these two R's are similar, same, identical. So we cannot multiply by 2 to find the different arrangements, because either this R is coming here or here, it is going to be same. So we'll only talk about the remaining places. Of course, there are 9 places. Now the question is, the condition is the 2 A's are not together, and we can find this by finding the total arrangement when there is no condition, and then we'll subtract the condition when they are coming together. So no condition for these 9 places. It is going to be 9 factorial, and 2 R's are gone now. So 1, 2, 3, the 9 letters are there, and then 2 L's and 2 A's are there. So it is going to be 9 factorial upon 2 factorial into 2 factorial. Now the conditions A's are together. So if A's are together, let's take, I'll write A here for instance. Let's say both A are coming here. They are coming together. So in this case, we can take them as one unit. If we take them as one unit, then these 2 are also gone. We will take it as 1. So there are going to be only 8 letters to be arranged. So we can arrange the 8 letters. We can, it's like we bind them together. They cannot move anywhere else. So there are going to be 1, 2, 3, 4, 5, 6, 7, 8. So the total arrangement when they are together is going to be 8 factorial divide by only still 2 L's are left, A's are not there, R's are not there, so we'll only divide by 2 factorial. So the condition, the total number of arrangement, total number of, or we can say required arrangement, would be 9 factorial divided by 2 factorial minus 8 factorial divided by 2 factorial, and that would be, I'll calculate from calculator, 9 factorial divided by 2 factorial into 2 factorial minus 8 factorial divided by 2 factorial, and it is coming 70,560 different arrangements. So that's it. I hope it is clear. Let's discuss the next one now. And here's the C part of this. Find the total number of different selections. This times we are going to deal with the selections of 6 letters from this 11 letters of the word caterpillar that contain both R's and at least one A and at least one L. So when there is a condition and the question is of selection, that is combination, we need to, it's better to sketch or draw or find the scenario. We'll draw the scenario what we are doing. If we require the 6 letters, it means I'll make a place 1 2 3 4 5 6. So it is given that both R's are there, so it means both R has to be there, so they are filled in all the scenario. The next one is, it says that at least one A should come. So one condition is there should be at least one A. There can be 2 because there are 2 A's, and at least one L, so it can be 1 L. This has to be there. Now we have to deal with the other possibilities. So again 6 places, 1 2 3 4 5 6. 2 R's are definitely coming. Let's say 1 A, and after 1 L there is another possibility for A. I am putting A here, so only one place is left. Next condition, 2 R's are of course fixed. Now 1 A and 1 L has to be there. Now in place of A I am taking only 1 A and there are going to be 2 L. This can be one condition. And the last one after 2 R, we can take both A's and we can take both L's. So this is the only condition. There is no other possibilities left, because we have dealt with one, at least one means 1A and 1L, or 2A 1L, or 1A 2L, and the 2 A's and 2L both. So we only have to find the selection. We'll select only for these empty places. So here we can see the 2 A's. If this is A, it means we are talking about only one A here, so it cannot be filled with A, so both A's are gone. Similarly both L's are gone and R's are already selected. So we are left with only 1 2 3 4 5 letters. So if 5 letters are left and we have to choose 2, so we can choose in the 5C2 ways, that is 5C2 is 10. And for here again the same thing, only for one place it is going to be 5C1, that is of course 5, and similarly for this case as well it is going to be 5C1 5, and this can be done in only one way, because they are like every space is fixed, so it can be done in only one way. Or we can write 5C0, that's not a thing, but we can understand, like I'll write 5C0 means we are not choosing anything out of these 5. So 5C0 is 1. So total number of different selections would be 10 plus 5 plus 5 plus 1, that is 21. So these are the total number of different selections of 6 letters with this condition. I hope it is clear. And here's the 7th question. There are 400 students at school, like 400 students at school in a certain country. Each student was asked whether preferred swimming, cycling or running, and the results are given in the following data table. We can see male and female also, swimming, cycling and running. A student is chosen at random. First part is to find the probability that the student prefers swimming. So it means we are going to, and we know the probability means favorable case upon total case. So they are only talking about the swimming. It means these are the possibilities. So we'll calculate for swimming only. It means the required probability we can write S for swimming. So swimming, the total number of students who prefer swimming is 104 plus 31, and of course we'll divide by the total number, that is 400. So it is going to be 135 over 400, and we should always write our answer till the most simplified answer. So we can write it as 27 over 80, and that's the required probability. Next part is to determine whether this events the student is male and the students prefer swimming are independent. Justify your answer. So we know for the independent events we calculate if we have two events A and B and we want to find whether they are independent or not, we can take their intersections probability and we'll calculate if this is same as probability of A into probability of B, then they are independent, otherwise they are not independent. So here we can take the student is male as, let's say, an event as M, and student prefers swimming, we can take it as S. So this condition become, we can write this condition as probability of M intersection with S is same as probability of M into probability of S. Then it's like if this, then independent. So first of all we need to calculate. So I'll calculate here only because otherwise I need to copy this table. M intersection S means the student is male and he prefers swimming. It means we are only talking about this condition. We can see this is 31 are male and prefer swimming, so it is coming in the intersection. So the probability of M male and prefer swimming is 31 over total complete means total number 400. And now we already have probability of S from the first part. We can see it is 27 over 80. We only need to calculate the probability of M. So probability of M means what is the probability that out of 400 there are male. This is the student is male. So it means we need to calculate the total here, and this total male are 31 for swimming, 57 for this, and 92 for running, and divide by 400. This is going to be 31 plus 57 plus 92, 180 over 400, or we can write 18 over 40. And P of S, probability that student prefers swimming, is given from the first part as 27 over 80. Let's calculate now. So here we can see that if we calculate the product of these two probability, 180 means 18 over 40 into, we are calculating probability of M into probability of S into 27 over 80. So we'll calculate this. 18 divided by 40 multiplied by 27 divided by 80, it is coming 243 over 1600, and this is certainly not same as 31 over 400. If you multiply by 4 in numerator and denominator, then also it is not going to be same here, and means we can say that they are not the events are not independent, and we have justified our answer. I hope it is clear. Here's the next part. On average, at all the schools in this country, 30% of the students do not like any sports. And B, first part, 10 of the students from this country are chosen at random. Sample size is given 10. Find the probability that at least 3 of these students do not like any sports. So they are focusing on do not like, and the probability on average means this probability is also given. Proportion means probability. So it means if we take n as 10, and if we talk about this as a success, that we choose at random any student out of this country, from this country, and that student does not like any sport, so we can take it as P, and it is given as 30%, means 0.30, and hence the failure means like any of this sport, it means Q is 1 minus P, it is 0.70. Now in that case it is the question of binomial, so we can take X as the number of students who do not like any sport, so it is going to be binomial. N is 10 and success probability is 0.30. So this question become finding the probability at least 3, so means X is greater than or equals 3. We need to find this probability, and of course it is not a good idea to go from 3 to 10 because they are asking for X greater than at least 3. So the best way is to calculate 1 minus, and we take the complement, and this is less than 3 or less than or equals to 2. So it become 1 minus, now it's a discrete value, less than or equals 2, it means we'll find the probability for X equals 0, 1, 2, all. So we know for binomial distribution the probability of X equals R is NCR P to the power R and Q to the power N minus R. So we are going to use this formula here. So we will get 1 minus curly bracket 10C0, P means 0.30 to the power 0 and 0.70 to the power 10 plus 10C1 0.30 to the power 1 and 0.70 to the power 9 plus the last 10C2 0.30 power 2 and 0.70 power 8. So we will calculate now by calculator. So this is the answer from calculator I have written. Now we will add them and then we will subtract. So sum of these all is going to be 0.121061 plus 0.028248. This is coming 0.38278. So this is going to be 1 minus, so this is 0.70 6, 1, 7, 2, 1, 6 and all. So till 3 significant figure, our answer is 0.617. I hope it is clear. And here's the second part of the BEEB and the last part of this paper. 90 students from this country are now chosen at random. Use an approximation to find the probability that fewer than 32 of them do not like any sports. So it's given as a hint that we need to use the approximation, and in AS level we only have the approximation from binomial to normal. Otherwise also we have to check, actually we should check for the condition, and the condition for the approximation from binomial to normal is n should be bigger than 15, which is of course greater than 15. So n should be greater than 15. NP and NQ both has to be less than 5. So let's check it. N is 15, that is correct. NP, and here P we have checked, it is 0.30, and hence Q is 0.70. So NP is going to be 90 into 0.30, 9 3s are 27. So 90 into 0.3 is 27, which is greater than 5. Satisfied? Oh sorry, I have written less than, so it is greater than always. There is everywhere it should be greater than, so it is greater than 5, satisfying. And again NQ is 90 into 0.70, that is 9 7s are 63, so it is 63. Again it is greater than 5, so it means we can approximate the binomial. I'll take it as x from binomial n, here 90 to, and p is, I like p here, we'll approximate by normal, and normal we have the parameters as variance, the mean and variance. From binomial the mean is NP, we have calculated here, that is 27, and NPQ is variance, so it is NPQ, we will calculate. So this become y is normal 27, and 27 into 0.7, it is 18.9. so that's the variance. Now the question is, find the probability that y should be fewer than 32, fewer than y should be less than 32. So one more thing, that is called continuity correction, because we have our question as the discrete and we have approximated to the normal, so there has to be continuity correction. And continuity correction, the best way is we have to choose the number, first of all 32 let's say, and let's say there is a gap, we will make a lower bound or upper bound in the way. It is like 31.5 here and 32.5 here. So this is a block for 32 in the discrete, this is a block. And the question is 32, y is less than 32. It means the best ways to decide is to if it is less than, not including, if you're not including the number, you'll not include the bar. Here the number is 32 and we are not including, so it means we cannot touch any number within this bracket, within this bar. It means we have to start our journey from 31.5. so the question becomes probability of y less than 31.5. less than or less than equals does not matter because it's a continuous distribution. So we have this, we are going to convert it into the standard normal distribution, that is z less than x, here 31.5 minus mu is 27 over sigma. Sigma means square root of variance, that is square root of 180 18.9, and we can calculate from calculator. This value is coming 1.035 till 3 significant figure. We'll write till 3 decimal place, and now we will calculate this by using the distribution table, and we can see it is z is less than, so we can directly calculate phi of 1.035. so let's check it. So let's check for phi of 1.035. so 1.0 is this column, 1.0, and then 3, so 3 is here, and then 5 comes here. So let's find the corresponding value for this. This is 0.8485, and addition will add to 5 means 12, so this value is going to be 0.8485, and since we are going to add 12, so we'll start from here 1 2, actually 2 and 1. It is always going to be multiplied by 0.0001, so this becomes 0.8497, and that's the answer. So the answer is 0.8497, and we write our answer till 3 significant figures. So we can see that third place is 9, and next is more than 5, so it is going to be 9 plus 1, so the answer is 0.850, and that's the answer. That's the probability. I hope it is clear, and that's it for this video. That was the last question. I hope it was of some help. So let's meet again in the solution of next paper in the next video. Till then, thank you so much.